All good, let's get started. Hello, everybody. We are here today to talk about how hybrid cloud GitOps platforms work, which is really timely because we just figured it out. So, my name's John Dietz. This is my co-founder, Jared Edwards. We are building a company of instant GitOps and infrastructure magic, basically. We have an open source foundation. We've been at the working toward the discipline of building instant free cloud native platforms for the last 5.5 years. As of the last half year, we started getting into the bare metal space. We're very, very excited. This is frankly the greatest week of our company's history. We've got the whole team here. We have been through a really long and challenging adventure, and it is all come to a great amount of success over the last half year. So we've got a new product that we are announcing called Colony for data center management and orchestration. And our open source platform, we are introducing a new commercial element to it this week. And we're rebranding our company. So Kubefirst, which we've been for the last 5.5 years as a company, is now Konstruct. So if you see the name, that's the relationship there. In order to talk about sort of why hybrid clouds matter, you kind of have to go through the evolution of machines and running software and running Kubernetes itself. And back in the old days, think back to, I don't know what, 2003-ish, everything was very difficult. If you needed to run software on a server, then you needed to purchase a server. If you needed more memory, if you needed more CPU, it was a very painful, bureaucratic, ticket-laden process usually, where you have to submit a ticket with your IT team and have them build a machine and rack it up. And maybe 15 days later, if you're working at a great company, then you'll have some place that you can put some software to run. Amazing. So if you fast forward just a little bit, what year was it? 14. Yeah. Yeah, it was like 2012-ish. AWS came out with their first ever public cloud. And the public cloud solved some really painful problems that we were having as an industry. It was difficult to get servers, and if you needed to estimate the amount of compute that you needed, you would hope that you were right, but you didn't know if you were right. And if you needed more hardware, that was a really big problem, and the public cloud changed the game considerably. And everybody left, it felt like. It was just an enormous rush toward the public cloud. And then just a couple years later, there were more public clouds, and with the dawn of engineering teams being able to own their own destiny, came the need to manage that infrastructure. And if you think back to the time, the configuration management tools of the day were of the ilk of Puppet and Chef, if you can kind of think back to that time frame. And it was really, it was close to as good as infrastructure as code, but it wasn't all the way there. And a lot of our solutions as an industry were very bespoke. You know, the right way to get software and operating systems onto machines was, if you go from company to company to company, it was a different story every single time. As you would try to build platforms to deliver software, it became a rather difficult undertaking to get the pieces to work together. We were reading software manuals to figure out how to install software instead of just Helm installing their latest chart like we do today. Kubernetes changed all of that. Kubernetes is not magic, but it's an exceptional framework that allows all software vendors to have a uniform way to install and run software. So the problem with Kubernetes was the control plane. There's perhaps a handful of problems, but one of the challenges is that control plane. Back in the early days of Kubernetes, running your own control plane, you guys are probably familiar with Kelsey Hightower's book, Kubernetes the Hard Way. Just very, very thorough, detailed operation and orchestration in order to get your control plane operational, and then you could join nodes to the control plane, and then you could run workloads in a relatively straightforward way. And really, all we cared about was that second half. We just want to run workloads. It's what we're trying to do. We're trying to build software. We're trying to run software. Managing the control plane, if anything goes wrong with your control plane, it's a very, very big problem. So the clouds began introducing managed control planes. It started with GKE, then EKS came out a couple years later, and that reduced the barrier of how much smart engineering you have to do to be able to begin your Kubernetes journey. Now you could just go into your public cloud and say, boop, I would like a Kubernetes cluster, please, and then before you know it, you've got a Kubernetes cluster. That was the catalyst for, I think, the entire Kubernetes swell. It was pretty hard work to get a Kubernetes cluster up and running and stable back in the old days, and now it's just not the case anymore. So the managed control plane solved a lot of problems. As Kubernetes gained that success and the market adoption and the engineering adoption and the community that it did, in began new distributions for Kubernetes. So distributions of the ilk of K3s, Talos, and they won't stop coming. There are going to be tons of distributions. If you just fast forward the clock 1 year, you can see it coming. So with the reduced complexity of these new Kubernetes distributions, now all of a sudden, it's not that hard to run and manage your control plane anymore either. Meanwhile, if you look at the industry and where we are right now, public clouds, generally speaking, I'm at Civo Cloud, and I don't feel this way about the Civo Cloud, but the industry feels like we're being nickeled and dimed, especially in the big three. You have costs that are coming from you don't know where. It's just, you're maybe just got a multi-AZ Kubernetes cluster, and there's all these network costs and egress costs, and everybody's getting a little frustrated with even trying to figure out what their cloud bill is. And with that frustration comes an attraction back to the data center. There are a lot of reasons to have, there are a lot of reasons to have a data center and to run your workloads in a data center. It could be for privacy reasons, compliance reasons, but another really great reason is cost. And if cost is paramount to you because you're running large-scale operations, or for a lot of organizations that have been around for 10, 15 years, they have commodity hardware already and would like to reuse that commodity hardware in a better way. And these lightweight distributions provide a really great way to establish that foundation. So we started looking into hybrid clouds, and we were trying to figure out the right way to orchestrate bare metal. Take it away, Jared. How did that go?
Yeah, so we're primarily working in most of the public clouds right now. Not all of them, obviously, but when we wanted to look into the bare metal space, we had a problem. We need hardware. That hardware is going to need networking stuff. It's going to need operating systems on the servers. That's going to have its own maintenance, network, hardware engineers, a whole new swell of stuff that we don't really have the capacity to take on. When you're doing your homework and trying to figure out how this all works, you also have a lot of internet information, which isn't always the most helpful to help you be successful. So we were lucky enough to we're working with Civo. They're helping us get data center space so that we can continue our path toward this hybrid cloud implementation that we want. And with that, we had to come up with something that would give us the ability to mimic what a data center would be before even they would be able to provide us with hardware. So getting hardware set up today isn't really much better. It still takes a lot of time. They still have to buy it. They have to get it set up in a data center. So with that, we set up a Vagrant ecosystem. It runs on a virtual machine, but that Vagrant ecosystem has everything from routers to switches to virtual network cables, everything that they worked with us on to make sure that we would be able to take on whatever that next challenge was of getting on the physical infrastructure. So go to the next.
I somehow lost my mouse.
Yeah, you did. So we had a video on his laptop that we were going to have playing in the background here, so we're just going to imagine there's a video on the screen now. But we went through the process of building this tool called Colony. Colony it looked much better when there was something here to talk to, but you'll just have to close your eyes and imagine. Basically, we're using the Tinkerbell ecosystem. And Tinkerbell is a cloud-native bare metal solution to help with automation. And so we have this ability to basically run the Tinkerbell ecosystem, but then be able to discover when hardwares are powered on and then be able to identify their MAC address, run some orchestration against those machines, and that'll be able to tell us more about the machine that we're installing to. And once we've identified what the machines consist of, then we have the ability to choose to run additional orchestration. When we get to that point, we're talking about being able to install like Ubuntu operating systems, turn those discovered hardwares into Kubernetes clusters of Talos or K3s flavors, and let's see, here's a quick example of what those Tinkerbell resources look like. So they give you all of our favorite language of YAML to identify and construct what these things represent. So you have every time you turn on a machine, you have a hardware object. That hardware object will give you the ability to then have a template that is the orchestration you want to run, and then that template will be run through a workflow. John, you just leave that one?
So Jared, what would you do once you had a Kubernetes cluster in your data center?
Yeah. So we believe that using GitOps is the best way to manage your Kubernetes cluster wherever it is, whether it's in a public cloud or a data center. Being able to have the disaster recovery as well as the very desired state effect of what you want a cluster to consist of.
There we go. Yeah, I'm happy here.
You're throwing me off. I don't know what else I was saying.
Yeah, no, having a GitOps ecosystem is just a better way to run Kubernetes software, frankly. It's the disaster recovery that it provides just by the way that it works. For those of you that maybe feel like you're familiar with GitOps, but maybe you're not, you use Git, you have ops, maybe that's GitOps, that's not GitOps. There's two main engines in our opinion. There's Argo CD and Flux CD are the two main GitOps ecosystems. They're both exceptional. They're both cloud native. They're both CNCF projects. They both have wide levels of governance of their repositories, and they're foundational tools that you should build your company on. The way that the technology works, you point the application at a Git repository and you say, look at this directory in the Git repository, and whatever's in there, put that in my cluster. And that's GitOps. So all you have to do in order to deliver software, you're no longer doing a kubectl apply, you're not doing a Helm install, you're just adding content to a directory in Git, which is a very stateful way from a desired state standpoint. That's what you want. You want a workflow where your engineers are able to pull request the changes that you want to your system, to your applications, to your infrastructure, and then have a system that's responsible for the enforcement of that desired state. So this is an example of what a GitOps platform might look like. This is the Kubefirst open source platform, which is the project we've been working on for quite a while. And it's got some of the most free and open source tools available in the cloud native landscape, all stitched together and ready to go. So if you ever wanted to check out like a GitOps platform and how it feels and how it works, you can have one for no strings attached for free. Just brew install Kubefirst and run a Kubefirst install. What we do with this implementation is you basically install, and then you have to create a cluster, and then you have to bootstrap that cluster using GitOps. And Jared, can we go into the various layers of what would constitute a good platform in your management cluster?
Yeah, so generally we'll have some form of a control plane. We want to be able to use infrastructure as code to create everything that we can. And with that, you'll probably have something like Atlantis that's going to be able to help automate all of your Terraform that you're running. Or you could use something like Crossplane if you want it to be more Kubernetes control plane based. We have Argo CD as well as part of that ecosystem to help manage the applications themselves, but then in the Crossplane space, also manage those Crossplane resources and help provision them.
And then users and secrets is another area of the platform that you're going to have to accommodate. So you're going to have different engineers that have different responsibilities and roles within your organization. And it's really important to get that part of your platform set up front, because rewinding the clock and dealing with IAM after the fact is a little bit of a monster. We use Vault internally for our user ecosystem, as well as for secrets. Most people that use Vault use it for their secrets management. They have a really nice KV store for storing secrets. We don't have our applications directly connecting to Vault. We use external secrets operator, and that's a nice platform abstraction layer from your secrets engine, so that if you decide, for example, that maybe HashiCorp Vault is not for you because, oh, I don't know, maybe they just changed licenses a second ago. In that predicament, it's really nice to have external secrets operator as that abstraction layer, so that you can say, I'm not using Vault anymore. Now I'm going to use cloud secrets. Now I'm going to use some other secrets engine. And all you have to do is change the back end of that secrets operator, and none of your applications need to know that anything happened from a platform standpoint on your secrets.
There's generally going to be some CI ecosystem. You're going to need to be able to produce images for your applications internally, Helm charts, any kind of artifacts that are going to be what represents your application space for your engineers that are trying to deliver software.
And then there's also the ingress element. You're likely adding applications to your Kubernetes cluster because people are going to need to access it. And for that access from the outside world into your cluster, you need something that's going to tend to that level of access for certificates that you're going to need, so that you can have secure communication. For DNS, so that as you're adding services in a very ephemeral way and services are coming in, it's very nice to have an engine keeping an eye on all of your ingresses and mapping A records in your DNS hosting system to the load balancers that are being created on your platform. And here's where we get into hybrid land.
Yeah, so with all of these foundations that we have of being able to leverage GitOps and these automated infrastructure as code tools, now that we can create Kubernetes clusters easily in bare metal spaces, we have the ability to move those control plane elements out of a public cloud Kubernetes cluster and into the data center Kubernetes cluster. And by being able to share or give your credentials to your private data center, you'll be able to provision downstream in the clouds, whether it's through Terraform or Crossplane or Pulumi or whatever your infrastructure as code tool is. providing access to your private data center allows you to get those same resources in the public cloud the way that you do today.
Right, and there's different ways that you can manage, there's all kinds of different hybrid cloud ecosystems. There's the type of hybrid cloud where you want the majority of your workloads in that private data center, and you just want the elasticity of the cloud. And for that type of an environment, you do have to tend to the traffic coming into your application space, because you have some of your workloads running in a data center, you have other parts of your workloads potentially running in a cloud. So you can be it can be as straightforward as just managing that at the DNS layer. You can have a vanity DNS that points to both your data center applications as well as your cloud applications, and just lean on your DNS provider for routing traffic to the appropriate place based on geolocation or anything of that ilk. And yeah, a little bit high level, hard to describe a hybrid cloud in 25 minutes. That was our best shot at it. Can I open up the conversation to you guys? Does anyone have any questions about hybrid cloud ecosystems or Tinkerbell or any of the details that we covered today? All right. Well, I think that's a wrap, and thank you guys so much for joining us today.